Thanks, Jason, for the introduction, and welcome everybody to the session. In many real-world markets, consumers perform an order search. An order search is a phenomenon whereby consumers explore firms according to a fixed ordering. Think, for example, of a consumer who uses the internet to purchase a product they are interested in. Typically, a web search engine lists the products from the top to the bottom of a web page, and the consumer will explore them accordingly. In this paper, I studied order search in a simple price competition model in which consumers are boundedly rational. In particular, consumers, instead of performing a complex calculation to derive the optimal stopping rule, are assumed to follow the satisficing heuristic or procedure proposed by Herbert Simon. In other words, consumers have in mind an aspiration price, the price that they regard to be satisfactory, explore the firms sequentially, and follow a simple rule of thumb. Stop searching as soon as you find a firm that charges a price that meets the aspiration price, and keep searching otherwise. Where crucially, the aspiration price, the price regarded as satisfactory, is influenced by firms' advertising strategies. The motivation behind the work is threefold. First of all, while there is extensive standard industrial organization literature on order search, relatively little is known about it when consumers are boundedly rational. So one of the paper's main objectives is to fill in this gap. Secondly, there is experimental evidence in support of the hypothesis that individuals behave according to the satisficing heuristic. And third, the behavioral implications of satisficing have been extensively studied in the choice theoretical literature and can be used to inform the modeling assumptions. I'll skip the discussion of the related literature due to time constraints and straight away present my simple model. A set of n profit-maximizing firms produce a homogeneous good at zero costs. Order search is specified as follows. Firm I is explored before firm J if and only if I is smaller than J. So firm 1 is the prominent firm, firm is explored first, and so on and so forth. In terms of firms' decision variables, firms are assumed to simultaneously choose a price from the unit interval and a costless advertising strategy A. For notational simplicity, advertising A can be either equal to 0 or equal to 1, or we can interpret A equal to 0 as no advertising and A equal to 1 as advertising. Firm 1, the prominent firm, is assumed to choose only a price and not an advertising strategy. This assumption is made purely for convenience because it can be shown that under any variant of the model studied in this paper, firm 1 always prefers to advertise than not to advertise. So for notational convenience, firm 1's advertising strategy is not explicitly modeled. Like in the price frame competition literature, advertising is persuasive and is meant to influence the consumer's aspiration price, the price regarded as satisfactory. Consumers, on the other hand, explore firms sequentially and are heterogeneous in various respects. A fraction E of consumers always look for the best deal in the market and are advertising immune. We can think of these consumers as fully rational consumers, or the literature as also refers to them as shoppers. Fraction 1 minus E of consumers behave according to the pricing heuristic, and their aspiration price is influenced by firms' advertising strategies. Satisficing consumers are themselves heterogeneous in the sense that they can have heterogeneous aspiration prices. And in particular, they can have either a low aspiration price equal to 0 or a high aspiration price equal to alpha, where alpha is an exogenous positive parameter. And persuasive advertising increases the fraction of consumers with a high aspiration price equal to alpha. In the next slide, I'm going to make precise how advertising affects aspiration prices. Given advertising profile A, I'll denote by capital rho of A the probability distribution over the set of aspiration prices 0 alpha induced by A. Specifically, I'll denote by small rho of psi A the probability that consumers have an aspiration price equal to psi at the advertising profile A. I don't impose any structure on the probability distribution other than two assumptions. The first assumption is a first-order stochastic dominance assumption that is defined as follows. For any pair of advertising profiles A and A prime such that A is larger than or equal to A prime, rho of A first-order stochastically dominates rho of A prime. The economic interpretation of this assumption is that one or more firms switching from no advertising to advertising increases the fraction of consumers, satisficing consumers, with a high aspiration price. The second assumption, which is called minimum market satisficing, says that the probability that satisficing consumers have an aspiration price equal to alpha when all firms choose not to advertise is strictly larger than zero. An economic justification for this assumption is as follows. Recall that firm one's advertising here is not explicitly modeled because it's always in the interest of firm one to advertise. So the fact that the probability that satisficing consumers have a high aspiration price when all firms except firm one do not advertise can be seen as the result of firm one's unmodeled advertising strategy. An important question is clearly how should we interpret advertising. So in the paper, I discussed various examples, and here, due to time constraint, I'm going to very briefly discuss one of them. Marketing science and psychology literature have shown that affecting the perceived time available to the consumer to make a purchasing decision has an effect on their search efforts. So advertising or high advertising, if you like, can be interpreted as firms putting in practice advertising strategies aimed at reducing the perceived time available to the consumer to make a purchasing decision. In the paper, I consider three variants of the model capturing the nature of the consumer's second best strategy if they do not find anything satisfactory. Best satisficing, meaning consumers purchase from the cheapest unsatisfactory firm. Last satisficing, meaning consumers purchase from the last discovered firm. And satisficing or none, meaning that they purchase nothing. Observe also that if all consumers are fully rational or shoppers, then the proposed model reduces to standard Bertrand. Therefore, from now on, I'm going to assume that parameter eta is so that the fraction of fully rational consumers is strictly smaller than 1. I'll now begin the analysis part of my presentation by starting my discussion on the duopoly case. There are going to be two firms in the market. Firm one is going to be the most prominent firm that all consumers will explore, and firm two is going to be the less prominent firm the consumer can possibly explore. And I'll begin with the discussion or analysis of the best satisficing variant of the model, meaning if consumers don't find anything satisfactory, they purchase from the cheapest unsatisfactory firm. So I'll begin with a few preliminary observations. Observe to begin with that best satisficing consumers that have a generic aspiration price equal to Xi will behave like shoppers, or if you like, fully rational consumers, if and only if firm will charge prices greater than Xi. So if you apply this observation to the present price competition model, we can realize easily that in charging prices greater than alpha, firms will engage in Bertrand competition. Therefore, by Bertrand arguments, firms will charge prices smaller than or equal to alpha in equilibrium. But given that we are studying order search and consumers explore firms sequentially, this implies that the satisficing consumers with a high aspiration price equal to alpha will purchase from firm one, the prominent firm, in all equilibrium realizations, implying that firms, the two firms, firm one and firm two, will compete only for shoppers, or if you like, fully rational consumers, and satisficing consumers with a low aspiration price. Now, these observations, along with a few other more technical ones, lead to the following result. There exists a unique equilibrium with the following properties. In terms of advertising, firm two will choose clearly not to advertise because its objective is to make the consumers as search active as possible. In terms of pricing strategies, as far as firm one is concerned, firm one has an atom at alpha. Remember, alpha is the high aspiration price of size 1 minus psi. And with residual probability, firm one randomizes according to the following CDF. Now observe that the support of this CDF is a connected interval whose supremum is indeed alpha, the high aspiration price, and whose lower bound is a positive price smaller than alpha. Observe also that psi is defined as the summation of two addenda. The first addendum is the probability that consumers are shoppers or fully rational. The second addendum is the probability that satisficing consumers have an aspiration price equal to 0. In terms of pricing strategies, as far as firm2 is concerned, firm2 does not have any atom, but randomizes according to the same CDF. This equilibrium has the property that firm1, the prominent firm, makes higher profits than firm2, the less prominent firm. And this result is entirely in line with the standard industrial organization literature on order search, according to which prominence and profits are positively correlated. The equilibrium has also the property that conversion rates decrease with prominence. That is, despite the fact that the prominent firm1, makes higher profits than firm2, the less prominent firm, exhibits higher conversion rates, meaning that buying customers are more likely to buy from lower positions. This result is consistent and can help explain well-documented empirical evidence. I'd now like to move on to the discussion of the second variant of the model, last satisficing, by still looking at the duopoly case. Remember, last satisficing means that if consumers do not find anything satisfactory, they'll purchase from the last discovered firm. The next proposition partially characterizes the equilibrium, as you will see very shortly, the implications, the strategic implications of last satisficing are very different from the best satisficing variant of the model. In every equilibrium, the following properties are satisfied. So first of all, in terms of advertising, firm2 chooses again not to advertise, because again, it wants to make sure that consumers are such active as possible. In terms of prices, and here is a key difference with respect to the previous case, if satisficing consumers with the lowest aspiration price are sufficiently many, then firm2 has an atom at 1, where 1 is interpreted as the consumer's maximum willingness to pay for the product. Firm1 can secure strictly positive profits by charging the high aspiration price alpha, and the profit lower bound is given by alpha times the probability that satisficing consumers have a high aspiration price, which turns out also to be the maximum value of the game that models this equation. It also secures strictly positive profit, and in particular, the lower bound is given by the probability that satisficing consumers have a low aspiration price. So what is the meaning of this result, and what is the economic interpretation of it? What's happening here is that consumers fail to anticipate that if they reject firm1's price, then they will end up purchasing from firm2, the last discovered firm, no matter what price it charges. Of course, firm2 will take advantage of that, and as long as satisficing consumers with the lowest aspiration price is many, then firm2 will have an incentive to charge the highest price, the consumer's maximum willingness to pay, which is greater than any consumer's aspiration price. And as a result of that, firm2 can make higher profits than firm1. So in other words, the less prominent firm can make higher profits than the prominent firm. This result drastically departs from the standard IO literature on order search, according to which prominence and profits are positively correlated. The result in the last satisficing case are also related to the concept of recency bias, which was originally studied in the field of psychology and more recently has been applied to internet search. Moreover, these results can also help explain well-documented evidence on the relationship between prominence and profits. So, for example, Arwal et al. Point out that contrary to the conventional wisdom in the industry, the topmost position is not necessarily the revenue or profit maximizing position. I'd like to present one last result. According to what we've seen so far, we've looked at two cases, best satisficing and last satisficing. We have seen that in the duopoly case, consumers get exploited in the sense that consumers end up paying a price that is larger than the marginal cost of production. So a natural question is to ask what happens if the market is made more competitive. This is a non-obvious question because a key issue, a key theme in the behavioral industrial organization literature is to investigate whether departing from the full rationality assumption alters the effectiveness of standard competition policy tools. Now, the next proposition addresses this point and says the following. The following two statements are equivalent, there are at least three firms in the market. Secondly, independently of the variant of the satisficing heuristic consumer use, there exists an equilibrium at which firm 1 charges alpha and at least two other firms charge price equal to 0. Now, there are this equilibrium satisfies three noteworthy properties. First of all, this equilibrium is competitive-like in the sense that there are some firms in the market that charge a price equal to the marginal cost of production. So in that sense, competition benefits consumers. Secondly, this equilibrium has also the property that for every aspiration price, in a set of aspiration prices, there exists a firm in the market that charges the aspiration price with probability 1. So this means that all satisficing consumer types here are satisfied. They don't need to rely on the second best strategy. So I call this equilibrium an all satisfied equilibrium. And that is the reason why the result holds independently of the variant of the satisficing heuristic consumer use. And third, this also implies that competition, or rather increasing competition in the market, neutralizes certain aspects of the consumer bundle rationality by making their second best strategy inconsequential. I like to conclude by briefly summarizing the main findings of the paper. I did not have time to discuss all the findings, but the main findings are the paper delivers predictions that help display empirical evidence, and I have talked about a few of them. The paper provides extensions of the basic framework, which I did not have time to talk about, which includes discussion of or analysis of endogenous prominence and a discussion of the relationship between customer satisfaction and profitability. The paper also discusses policy implications of the bundle rationality model, in particular by showing that making the market more competitive benefits consumers. The program committee members who reviewed this paper all agreed that the main weakness of this paper is that the model is simple or simplistic, and they provided some advice or some suggestions on how to make the model more sophisticated. And I'm happy to talk about these in case somebody has any questions.